In the previous video, we were talking about computing internal rate of return when you have non-conventional cash flows, and this was the example we used. The first cash flow was minus 90,000, then you had two positive cash flows, then you had a negative cash flow. And we looked at a spreadsheet and a little graph here, and we saw that as you get two places where net present value, this is the NPV profile, crosses this axis. That's where NPV equals 0, and that's what would be our internal rate of return. So you can see it's a little bit, it's around 10% here, and it's 42.5% or so right here. So you get two solutions. And if you're using a required return of 15%, you would reject it here, but you would accept it here. So this is a problem. So there are a couple of approaches we can take that are an approach that's known as modified internal rate of return. Problem is there are three methods for calculating this, and let's go over these three right here. Method one is what's known as the discounting approach. And in the discounting approach, we bring the future cash flow, we bring the cash outflows back to the present. So in this case, the outflow is going to be equal to minus 90,000 plus we're going to bring the negative 150,000 in year 3 back to time 0. And we're going to discount by the required return, which is 1.15, and we'll raise that to the third power. So let's see what we get here. We can use our time value of money worksheet. So we have 3 periods. We're going to use an interest rate of 15%, and we're going to have a future value of 150,000, and we'll compute the present value, 98,627.43, and we're going to add the 90,000 to that, or actually the negative 90,000. We got a negative number for this. So your cash outflow is minus 188,627, and we'll ignore the pennies. So now you have a project where there's one negative outflow and then two positive inflows in year 1 and year 2. And you just compute NPV. So let's use our cash flow worksheet. Let me clear that. Again, you clear it by hitting second, clear worksheet. So the cash outflow is 188,627. Make that negative. And we make sure you hit enter and see that equal sign. The first cash flow is 132,000. So we'll hit enter, and it only appears once, so frequency is 1. Leave that alone. We have a $100,000 cash flow. Enter, and that frequency is 1. And let's compute the IRR. And we compute it, and we get an IRR of, or actually an MIRR, modified internal rate of return, that's equal to 15.77%. So in this case, if we have a required return of 15%, we would accept this project. So we get the same solution we got when we used NPV. Okay, NPV being already calculated up here at 1,069. It's positive, so we accept the project. All right, how about method 2? Method 2, so this is method 1. Method 2 is the reinvestment approach. And in this case, what we're going to do is we're going to assume that all of the cash flows, except for the first one, this one in year 0, are brought out to year 3, and they're brought out at some interest rate, which we call the reinvestment rate. Now we could use the required return, but I'm going to use a different return. I've actually done it for the required return, but let me do it for a different reinvestment rate. When I do it for the same 15%, I get about 15.3%, so I get a little over 15%, but in this case I'm going to assume that the reinvestment rate is equal to 10%. All right. What rate do you choose? Well, that depends. What do we mean by reinvestment rate? We're saying that when you get this cash flow in year one, you reinvest it at a 10% rate. So even though you require 15% on the project, maybe you can only put it in the bank and earn 10% on it. And then this amount is also reinvested at 10%, etc., etc. So let me do that calculation for you. So the cash flow in year 3 is going to be equal to 132,000 times 1.10 squared, because that's the year 1 cash flow, and we're bringing it out to year 3, so that's 2 periods, plus 100,000 times 1.10 minus 150,000, or plus a negative 150,000. So let's see what we have here. We're going to take 1.1 and raise it to the second power, and then multiply it by the 132,000, and we get 159,720. 100,000 times 1.10 is 110,000. So let's add 110,000 to that. And then we subtract out the 150,000. So we get that this cash flow is $119,720. So we've taken, so we only have 2 cash flows now. We have the minus 90,000 in year 0, and we've taken everything out to year 3, and the 119,720 in year 3. Okay, year 1's cash flow is 0. Year 2's cash flow is also 0. So let's just go back. We'll use our financial calculator again. And so the first cash flow is minus 90,000. Enter. The next cash flow is 0. Hit the enter key so it registers. And that's going to occur twice. And then our last cash flow is 119,720. And let's hit enter. And then we can go and we can compute the IRR, and we get this modified IRR here. Is equal to 9.98%. So in this case we would reject the project. If we used a reinvestment rate of 15%, we will get around 15.3%. I've calculated this before. In fact, I made this video several times, but I went over my 15-minute limit that YouTube allows me to have, so I'm going to shorten it, and trust me, you can calculate it for yourself. If you use 15% in here, you'll come out with an IRR a little over 15%. So the third and final method we'll look at is the combination approach. And the combination approach is where we take the negative cash flows, or we take the outflows back to year 0, we take the inflows out to the last period. So the outflows in this case are going to equal minus 90,000 plus the present value of the 150,000. Okay, well, we're bringing it back here. I'm bringing it back by 15%, because that's a required return. We're not reinvesting. So I'm going to get the same number I had before. I recalculated this. So I got 188,627. Minus 188,627. All right, now the inflows I'm going to bring out into the future using the reinvestment rate. I suppose you could bring this back at 10%. I'm going to stay with the 15%. So in this case, you would have 132,000. And we're going to bring it out to the future by multiplying it times 1.10 squared plus the 100,000 times 1.10. Okay, we've already brought the 150 back, so we don't add the 150 in there. So let's see what we get here. This is going to be 1.1 raised to the second power times 132,000. 100,000 times 1.10 is 110,000, so let's add 110,000 to this. So we get 269,720. And let's go back to our cash flow worksheet. All right, the first cash flow, I'm not even going to erase this because I'm writing over these numbers anyhow. 188,627. And that's negative. And then the next cash flows are 0, and that they occur twice. And the final cash flow is 269,720. Enter. And then we're going to recompute this IRR, and we get, in this case, the modified IRR is 12.66%. So again, with a 15% required return, we would again reject this project. So you can see that first, it's a little more tedious. You have to do some extra calculations to get this to work. Second, you have to make an assumption on what the reinvestment rate is. Is 10% a realistic reinvestment rate? Should we use 12%? Should we use 15%? I calculated using all three methods using 15%, and all of these modified internal rate of returns came out a little over 15%, so we would accept all of them. It's hard to know. In fact, some people refer to this MIRR as meaningless internal rate of return because it's not clear what numbers you use. If you use net present value, you always get the right answer. In this case, accept this project at a rate of 15%. I'm not going to do it here, but Excel also has a modified internal rate of return function. I believe it does the combination approach, but you should check. You shouldn't just accept that it's calculating something for you. You should put the numbers in and see what you get. And try out these numbers since we know what the answers are and see which method it's actually using to compute this. But again, a little more tedious, a little bit more of a pain. Net NPV always gives you the right answer. IRR oftentimes does, but in this case, it may give you an incorrect answer.